Going once. Twice. I am surprised they had a lot of questions on third block. Yes. Yes, I will be happy to. Can you, I don't have a sheet in front of me. Can you tell me what the problem is? And then what? Like that? Okay. So the first thing is still the same. I'm still looking for a GCF. That's always my first step before I factor. So here, does this have a GCF? Yes, and it's just Y. So a couple of you texted me about this last night, 17 and 18. And I told you to first take out the GCF, bless you. And now look at the parentheses. What do you notice? I hope you noticed something. They're both perfect squares, so I can take the square root. Because there's a subtraction sign in the middle, and they're both perfect squares, I can do that difference of two squares we talked about yesterday. So remember, if I have a squared minus b squared, then I can factor that as a minus b, a plus b. So here, the y is still outside. What do you multiply 2 times to get 64x squared? 8x. That's right. And what do you multiply 2 times to get 1? 1. So I do 8x minus 1, and then I do 8x plus 1. That's all you had to do there. Anything else on that homework sheet? Y'all sure? Okay. Actually, before I show you factor and solve, let me show you one more special pattern. Yesterday, we did the difference of two squares. Bless you. And we said that's where there's the subtraction sign in the middle. I'm just going to recopy exactly what I just told you. And we take the square root of each and split it up this way. But there's one other special pattern that, again, you don't have to know this one just yet, but it'll be really beneficial if you do, because we'll get to a section later in this chapter where you do have to know it. And so this last one is called a perfect square trinomial. It is the hardest to recognize, but it is the easiest to factor. And there are a lot of different things you have to look for to recognize it being a perfect square trinomial. So let me go through several of them with you and show you what you have to recognize. All right. The first thing is this trinomial part, which tells me what? What's tri mean? 3, right? So it's going to have 3 parts. 1, 2, 3. The first term, okay, so this very first blank, this one must be a perfect square, and the last one must be a perfect square. The last sign has to be a plus. Okay, so here's requirement number 1, requirement number 2, and then the third thing is the one that makes it the hardest to recognize. If I said that this perfect square, let's just call it a squared, and let's call this last one, we'll call it c squared since we've been calling c that last number. If that is true, then the middle has to be 2 times, so this is the third requirement, 2 times whatever number multiplies by itself to give you the first one, so 2 times a times whatever multiplies 2 times to give you this last one, so times c. And that's what has to sit in the middle, okay? So as long as those three things happen, you have a perfect square trinomial. And I know this is a little bit confusing here, so stick with me. So this is a squared, c squared, and 2ac. This first sign could be plus or minus. If those three things happen, then to factor it, all I have to do is the square root of the first one, whatever this first sign is, and then the square root of the last, and I put a squared on it. Let me show you an example, because it's a little easier to see with an example. Let's say I had x squared plus 6x plus 9. My first question is that a perfect square trinomial? Let's go through our three checkoffs. First thing is, are the ends perfect squares? Yes and yes. Is the second sign a plus? Yes. Is the middle 2 times the product of the square roots of the ends? In other words, what times itself twice gives you x squared? 1x. What times itself 2 times gives you 9? 3. If I multiply those two things together, I get 3x. And then I double it, do I get what's in the middle? Yes. So yes, this is a perfect square trinomial. And now I can factor it very easily. That tells me that because it's a perfect square trinomial, then it factors as the square root of the first, the very first sign, and the square root of the last square. I don't have to multiply the first and the last together. I don't have to find the factors that multiply and add. I can just use the shortcut. Okay? And I know this seems like a lot to use that shortcut, but sometimes those squares get really big, and we're going to get to a point where we don't have this number and we have to find it and we have to create a perfect square trinomial. So I need you to be able to recognize what a perfect square trinomial is. Let me show you another one. You probably encountered some of these on your homework last night. Nope. Sorry. Yes or no? I hear yes. Let's do our checkoffs. Ends are perfect squares. Second sign is plus. This is always where it comes into question. If you take the square roots of the ends, what's the square root of 4x squared? 2x. What's the square root of 25? If you multiply and double, do you get what's in the middle? Yes. So how would this factor? 2x. What sign goes here? Is it a plus or a minus? Minus square root of the last, and then you throw the square root up top. Yes or no? The ends are perfect squares. Second sign is minus. Square root, multiply, and double. Do you get what's in the middle? No. So this is not a perfect square trinomial, and it is not just because of that middle. Does that make sense? Do you guys see what we're doing? If that middle term was a 14, it would be. There you go. You got to multiply and double them. That's why. Everybody okay? All right. So today we're going to be doing more factoring practice, but we're going to add a little something to it. Y'all need a break or y'all okay? Y'all don't even talk. I don't even understand. What can I do to make y'all talk to me? Oh my goodness. Where are you at? Are you on the red one? So I did the square root of the first and the square root of the last. Then you multiply those together. Don't worry about the sign because this sign can be anything. It can be plus or minus. And then you just double it to see the middle. That's what it has to be. Let's say I have two things, and I don't know what either of these two things are, but I'm going to multiply them together. I'm just going to put a random variable in here for both of them. If I told you that I multiply these two things together, and when I do, I get 0, tell me what you know has to be true. That's the only way to get 0, right? That just makes sense. To get 0, when you multiply one, at least one of them has to be 0 to make that true. That is what we call the 0 product property. At least one. And it makes sense because the only way to get 0, so if I plugged in 0 for x here, my equation would be true. If I plugged in 0 for y here, my equation would be true. So that's 0 product property, and that's what we're going to base solving our quadratics on. So if I have this, and I'm going to just start with it being factored, let's say, actually, let's say I gave you this equation and I said solve it for x. Your first instinct is probably to say move the 6, right? Or fix on that. But that's not going to allow me to get x by itself. Okay. But if I write it a different way, so if I were to factor this, and let's just factor it quickly and see what happens. What multiplies to 6x squared but adds to 5x? 2 and 3. So I got 2x and 3x. So now my equation, and I know I'm running through this quickly. 3x, 6. I'm going to slash it. What's my GCF here? X. And what's left? Middle sign stays. What's my GCF here? 3. And what's left? X plus 2. So in factored form, I have my x plus 2 and then x plus 3. So that's what we've been working on the past couple of days, right? But now, if you look at this, can you see that what I really have is something times something else? Do you agree with that? Kind of looks like my x times y equals 0 in the beginning. So in order for this equation to be true, I need x plus 2 to equal 0, and or I need x plus 3 to equal 0. Would you agree with that? Yes. So now I have two easier linear equations that I can go through and solve, and I can find the answers. And here, of course, I would just subtract 2. And here I would subtract 3. So a quadratic equation could have 2 solutions now instead of the 1 solution that I'm used to with linears. But here, if I plug -2 in, that would make that very first one 0. That would make the equation true. And if I plug -3 in here, that would also make that second one 0, which would make the equation true. Does that make sense? So let me make a kind of general statement for you. To solve quadratics, I'm going to say by factoring, because the entire rest of this unit that we're doing is all about different ways to solve quadratics. So this one is solving by factoring, which is always our go-to if we can ever do it. The first thing that I want to always do is move everything to one side so that the other side is 0. I can. You want me to run an example alongside it? Okay. Let's say, for example, so here's your example in blue. If I need to move everything to the same side, and I would make a note, always try to keep your leading coefficient positive. So move everything to the side where your leading coefficient will stay positive. Leading coefficient means that x squared term, that very first, that ax squared term, right? So what should I move here to make this equal 0? Not everybody at once. If you need to make that equation equal 0 and you want the very first one to stay positive, move the 10x and the 21, right? Does that make sense? If I move the x squared, it's going to be negative. So instead, I'm going to move the 10x and the 21. I'm going to keep it in standard form, so I have x squared minus 10x plus 21. Anybody lost or confused? Everybody okay? All I did was just move them over to the other side. Made it equal 0. I'm going to factor now. Okay, so now I'm back to what we were doing yesterday. And all those steps for factoring, I want to make sure I still do. So is there a GCF here? No, I don't see a GCF. So let's go ahead with the factoring. Multiply the first and the last together. What multiplies to positive 21x squared, but adds to negative 10x? That's exactly right. Negative 7x and then 3x. So I have x squared minus 7x minus 3x plus 21. The only difference here in what you've been doing is now it equals 0. Okay, it's an equation instead of an expression now. What's the GCF of the first two? What's left? That's right. The middle sign stays, but because that middle sign is minus, it's going to change this very last one, and that's okay. What's the GCF here? 3, and what's left? X. So factored, I look this way. Now remember, the goal of this is to solve that quadratic, okay? Any guesses on what I need to do now? Solve for x, how do I do that? I'm gonna set, y'all are saying it, but and you're right, I would add set, but what I'm gonna do is I'm gonna set each factor. Okay, this is a factor and this is a factor, because factors by definition are what multiplies together to give you something. So set each factor to 0 and solve, which is what y'all were doing. You just weren't saying that, but you were doing it. So here, that would mean x minus 7 equals 0 and x minus 3 equals 0, right? And I'm going to solve those two individually as I go through this. So add 7 and add 3. I'm going to put a little note under number 1. Keep AX positive. Two more examples I want to do with you that are kind of special cases. Whew. Is this a quadratic? Or no? Yes. Why? What makes you think it is or it isn't? It's got an x squared term, right? Could I get them all on the same side? Yeah. What would it be missing? C. Is it still a quadratic if it's missing C? Sure. That just means the y-intercept is 0, and that's okay. So it is still a quadratic, so I'm going to follow all the steps for solving a quadratic. So the first thing, make it equal 0. What do I move? Y. That's right. I want this to be positive. So instead of moving this over there, I'm going to move the 10x to the other side. So move the 10x. I can't combine those because they're not like terms, so it's just 3x squared minus 10x equals 0. Factor. Now the first step of factoring is to look for what? Common factor. Does it have a GCF? Sure? X. I could take out an x, right? They both have an x. Let's take that out and see what happens. If I take out an x, I'm left with 3x minus 10. Can I factor that any further? No, the squares are gone, right? That's as far as it factors, and that's okay. But how am I going to solve that? Well, but distributing, I mean, that would be my gut instinct, but distributing would just put me back here, right? Anybody else have any ideas? What's happening here with this x? You're multiplying. It looks to me like we have something times something else. Do you agree? So if I have two things multiplied together to give me 0, what has to happen? They have to equal 0. One or both of them has to equal 0. Well, here's the first thing. So either that's going to equal 0, or this is going to equal 0. Well, this one, luckily, is already solved for me for x. So now that just leaves one linear term that I have to solve for x. How do you solve that one? What do I do? Plus 10. And then what? Divide by 3. Leave it just like that. Don't try to do anything else with it. There are my two answers. One more. Yeah, that's it. Those are two answers. That's it. That was easy, right? They're not all that easy. This one's coming from your classwork / homework today. Let's see a little bit harder one. What should I do first? That's exactly right. I need one side to be 0, and I have to decide which side. And because I want this to stay positive, I'm going to move both of these to this side. So subtract 2 and add 3x. Now what? Greatest common factor. Does it have one? What's the greatest common factor? 4. If I take a 4 out, I'm left with x squared plus 11x plus 24. Now what? Okay. Is 4 ever going to be 0? No. In fact, what I could do here, since that's just a constant, is I say, well, what if I just divide it by all the sides by 4? And you don't have to do this now. You can keep carrying the 4 down, or if it helps you here, we could do it this way. Either way is fine. But what now? Still don't know what x equals, which was what I wanted to do. You factor it. That's exactly right. You factor it. So now the question is, what multiplies to 24x squared but adds to 11x? 3 and 8. There you go. So this one stumped me whenever I looked at it, because I was like, what? I kept wanting to do what y'all were doing, the 12 and 2 or 6 and 4, and I wasn't coming up. And maybe you do struggle with it, and you come over here and you say, okay, I know 6 times 4, I know 12 times 2, And you keep doing these until you find the one that works. And then you go, oh, well, wait, there it is. All right. At the bottom of my thing. Oh. All right, so I have x squared plus 3x plus 8x plus 24 equals 0. GCF of the first two. And what's left? That's right. The middle sign here. And what's the GCF of the last two? And what's left? Plus 3? That's right. No, that's okay. So now I have x plus 3, x plus 8. Now it's downhill from here, right? Set each piece to 0. And solve each one individually. No, and if you had carried it on down, so if you end up with something like this, 4 times x plus 3 times x plus 8. Remember, just one of the pieces has to be 0, but as you look, this is 3 pieces multiplied together, and if there was an x on here, it would be x equals 0. But because there's no variable, and 4 will never be 0, no matter what you do, then it's not part of the solution. Everybody good? All right, so I have you 18 problems to work on. Y'all asked so few questions that you'll have plenty of time to get through them. So it's a worksheet. I did print it off for you if you want it printed off. If you don't, it's on Canvas, but I